It's helpful to know how to break a number down into its prime factors. A prime number is a number that only has itself and 1 as a factor. Like, for example, the number 2 is a prime factor because the only numbers that will go into 2 are 2 and 1, so it's a prime factor. 3 is a prime factor because the only numbers that go into 3 are 3 and 1. Now 4 is not a prime factor because besides having factors of 4 and 1, the number 4 also is divisible by 2. So it is not a prime number. It would be considered a composite number. But 5 is a prime number. 6 is not a prime number because 3 and 2 both will go into 6. 7 is a prime number because it only has 7 and 1 as a factor. 8 is not a prime factor because now, since 2 is a prime factor, every even number after 2 will not be prime because it will have 2 as a factor. 8 won't be, right? 9 will not be a prime factor because it's divisible by 3. 10's not prime, but then we finally get to 11, and that's a prime number. No other number besides 11 and 1 will go into 11. 12's even, so it's not prime. 13 is a prime number. 14's not prime because it's even. 15's not prime because 3 and 5 will go into 15. 16's even, and 17 is prime. 18 is even, and 19 is prime. Nothing will go into 19 except for 19 and 1. For example, 3 won't go into it, 7 won't, 5 won't, and so on. 20 is not prime because it's even. 21 has factors of 3 and 7, so it's not prime. 22 is even. 23 is prime. And I'll just list a couple more here. 24 is even. 25 has a factor of 5. 26 is even. 27 has a factor of 3. 28 is even. 29 is prime. And you could keep on going with this and get more prime numbers. Now the reason you need to break numbers down into their primes is because when you're finding least common denominators or you're adding fractions, subtracting fractions, multiplying or dividing fractions, you may want to break the number down to the primes. So let's try one here. Let's take 54, the number 54, and break it into its prime factorization. Well, the first thing I know is since that number ends with a 4, it's an even number if it ends with a 0, 2, 4, 6, or 8. So if that number is even, then I know 2 will go into it. Well, let me take 2 into 54, and 2 goes into 54. Well, let's go ahead and do this here a second. 2 goes into 5 2 times. 2 times 2 is 4. And when I subtract that, I get 1. Bring down your 4. 2 goes into 14 7 times. So far we have 54 is 2 times 27. But 27 is not prime. Now what number will go into 27? Well, 27 is not even. So 2 will not go into 27. But 3 will go into 27. And a little trick to know if 3 goes into a number or not is to do this. Add up the digits. Like for example, 2 and 7 is 9. And if 3 will go into the sum of the digits, 3 will go into the number. So 2 plus 7 is 9. 3 goes into 9. So therefore, 3 will go into 27. So let me take 3 into 27. And 3 goes into 27 9 times because 9 times 3 is 27. So there's my 3. And then 9 breaks into 3 times 3. So there's another 3 times 3. And if you check this, this is the prime factorization of the number 54. 2 times 3 is 6, and 3 times 3 is 9, and 9 times 6 is 54, so that's the prime factorization. Let's try, well also I should tell you that we could write these prime factors this way. This would be the same as 2 times 3 to the third power, because 3 to the third power means 3 times 3 times 3. So that's another way of writing that prime factorization. Let's try another one here. Let's do the number, let's try, let's see, how about 45? That isn't too bad. Now, first of all, 45 is not even. So 2 will not go into that number. Now it ends with a 5. If a number ends with a 5 or a 0, then that means that 5 will go into it. Also, if you add the digits and the sum of the digits that are divisible by 3, then 3 will go into that number. Well, 4 and 5 is 9, and 9 is divisible by 3, so 3 will go into 45. I'm going to go ahead and take the 5 into this first and make it a little bit easier to deal with. 5 goes into 45 9 times, so the prime factorization of 45 would be 5 times, not 9, because 9 is not a prime number. 9 breaks into 3 times 3. So the prime factorization of this number, 45, would be 5 times 3 times 3, or 5 times 3 squared. And we'll stop this video right here, and we'll do another video on showing how to maybe use prime numbers to help multiply and divide fractions.